In class, we were discussing the chapter 4, which is fractions. And in this presentation, we will discuss the section 4.4, adding and subtracting fractions. Let's start. We can do a small review what we discussed before. Then in the previous classes, we say fraction is a number we can write in the form of a over b, where the a is the numerator and b is the denominator. Also, we learn how to multiply fractions, and if we multiply, for example, 3 to multiply by 5 over 4, then we need to multiply straight across, as this is. Then 3 times 5 and 2 times 4. Then 3 times 5 is 15, and 2 times 4 is 8. Also, we learn how to divide fractions. Then we say if we divide, for example, 1 over 2 divided by 3 over 5, then what we had to do is we keep the first fraction, we don't change anything, but then we change the division by the multiplication, and then just we multiply by the reciprocal of the second fraction, or we need to flip the fraction. And this one will be 5 over 8. Yes. And let's so different points. Also, we discuss about the mixed fractions. That fractions are fractions that had the integer part and fraction part. Integer part and fraction part. Then we say to convert mixed fractions into fractions, what we had to do is we multiply the integer part times the denominator. We add the numerator and we divide by 2. Then it's 3 times 2 plus 1 divided by 2. 3 times 2 plus 1 is 2 times 3 times 2 is 6 plus 1 is 7 over 2. And also we say if we had an improper fraction, proper fractions, then one improper fraction is the fraction which the numerator is greater than the numerator is greater than the denominator. As in this case, 7 is greater than 5, and this is improper fraction. Always, if we had improper fraction, we can express that fraction as mixed fraction. How we will do that? And we just divide. Yes. Then how many times 5 goes into 7 is 1 time. 1 times 5 is minus 5 is 2. Then always the quotient is the whole number, is the integer number. Then the remainder is the numerator, and the divisor is the denominator. And we can test this one. 1 times 5 is 5, plus 2 is 7, 7 over 5. Then just we review this one. We already discussed this part before, but just I want to review. And also, we also discussed how we add fractions if we had the common denominators. And we say if we had fractions with common denominators, what we had to do is just keep the denominator and add the numerators. If we had subtraction, we keep the denominator and we subtract the numerators. Then just again, this is just review what we discussed before. If we had, for example, 4 over 9 plus 3, we keep this one. This is 4 plus 3. And finally, we had 7, 9. And this is a proper fraction. Then we don't need to, we cannot convert this one in a mixed fraction. Then this one, this one we have 13 over 16 minus 15 over 16. Then we keep this one, 13 minus 15. We had different signs. We had positive and negative. Then we had to subtract the numbers. Will be 2. 15 is the larger number. Then the answer is negative. Then it's negative over 16. And we can reduce this fraction. Then will be, if we divide by 2, we will have negative 1 over 8. Let's do the number 3. And this we had minus 11 over 12 minus 7 over 12. And we keep the numerator. And then we, in this case, because both numbers are negative, we had to add the numbers together and keep the sign. 12. And we can divide by, by 3. Yes, we can divide by 3. Then we will have this. If we divide by 3, it will be minus 6 over 2. But we can divide by 2 again. Sorry, here. I had here mistake. We divide by 3, this will be over 4. We over 4. But we can reduce more. This one then will be minus, if we divide by 2, will be minus 3 over 2. And this will be minus 3 over 2. And finally, we had one problem in which we had variables. And here we had to be careful because we had 2 negatives here. Then we can multiply the negatives. We can say negative times negative is positive, or we can say the negative of the opposite number is always positive. Then we had, you can write this one like 2 over y. Because we had, even if there is variables, we had the same denominator. Then just we keep the denominator, which is y. In this case, we had negative 5 plus 3. We had to subtract the numbers, and the answer is negative because 5 is the larger number. Then the answer is negative 2. Oh, sorry, here is 2. And it's negative 3 Negative 5 plus 2 will be negative 3. Now we want to know how to add and subtract fractions if we had different denominators. For example, if we had 4 over 5 plus 1 over 6. And in this case, we can now apply the same procedure we did in the previous slide because we had different denominators. Then what we had to do in this case, if we want to add these fractions, first we need to find a common denominator for this fraction. How we will do that is we want to find equivalent fractions to this one to get a common denominator. And we want to find equivalent fractions to these fractions, to the original fractions, to get a common denominator. How we will do this one? The step number 1 is we need to find the LCD, the least common denominator. The least common denominator is the smallest number divisible by all the denominators for the given fraction. And just remember, in the integer chapter, we say the divisors and the factors of the numbers are the same, as the divisor and the factor of the same. Then this is why when we want to find the least common denominator, is the same as least common multiple, because factors and divisors are the same. Then just to review, the least common multiple is the small number that is multiple of each number of a given set of numbers. Then the LCD and the LCM, they are the same. And if we can find the LCM, the least common multiple is the same as we find the least common denominator. Then how we will find the LCD? Then first we want the step number 1 is list all the multiples of each number. Yes, if we want to find the LCD for 6 and 9, what we had to do is we had to list all the multiples: 6, 12, 18, 24, 30, 36, 42, 54. Then we need to list the multiples of 9. Then it's 9, 18, 27, 36, 45, 54, and just we can list just some of them. Then now we need to check what are the multiples that are in common. Yes, then we had 18 here. We had also 36, 36, 54, 54. But what is the LCD? Is the list of the multiples. Is the small, we need to pick the list of these multiples that are in common. Yes. Then we had 18, 36, and 54, but the LCD will be the list of the multiples. Then in this case, the LCD will be equal to 80. Then the LCD of 6 and 9 is 18. If we want to add these two fractions, yes, we want to add 4 by 9 plus 1 over 6. This is what we want to add. Then what we need to do is we need to find equivalent fractions. To find equivalent fractions, we will use the LCD. Then we know the LCD for these two numbers are 18. 6, and 9 equal to 18. Then we want to find equivalent fractions in which the denominator is 18 for both. Then we want to find equivalent fractions with 18 as the denominator. Then because we had here 9, what we had to do is we need to multiply by 2. But if we multiply by 2 in the denominator, we had to multiply by 2 also the numerator. And we multiply by 2 on top, we multiply by 2 on bottom to get 18 as the denominator. Then 4 times 2 is 8, 9 times 2 is 18. And we will do the same procedure for the other fraction. We want 18 as the denominator, then what to do is multiply the denominator of the original fraction by 3. But if we multiply the denominator, we had to do exactly the same in the numerator. We need to multiply by 3. Then multiply by 3 on top, we multiply by 3 on bottom. Then 1 times 3 is 3, 6 times 3 is equal to 18. Then now we had equivalent fractions. Then 4 nines equal to 8 over 18. 1 over 6 equal to 3 over 18. Now we had equivalent fractions with common denominators. Yes, we had equivalent fraction to the original fractions in the problem, but we had common denominator. And now we know how to add fractions with common denominator. Then just we add the numerators. 8 plus 3 is 11, and we keep the denominator. And the final answer is 4 over 9 plus 1 over 6 equal to 1180. Then this is the procedure how we add or subtract fractions with different denominators. Step number 1, we need to find the LCD. Step number 2, we need to create equivalent fractions in which the LCD value will be the denominator of the new fractions. Yes. And we want to create fractions using the LCD, and in this fraction the denominator will be the LCD, the LCD number. Then once we create equivalent fraction with the same denominator, just you need to add or subtract the fractions with common denominator. In this example, we want to add the fractions with different denominator. Then the step number 1 is we want to find the LCD. Of 4 and 5. And again, if you know what is the LCD of 4 and 5, then just go ahead and write the LCD. But if you don't know, then you can find the factors for 4. Then the factors for 4 is 4. List all the factors: 12, 16, 20, 24, 5. Will be 5, 10, 15, 20, 25. Now we need to select what is the small factor. Then we had the least common factor, then is 4, 8, 12, 16, 5, 10. We know is 12. And it's 12. And we'll say the LCD equal to 20. Then the step number 1 is to find the LCD. The step number 2 is to find equivalent fractions as with the 20 as the denominator. Then let's write again this problem is 3/4 minus 7/5. And to get 20 as the denominator, we need to multiply by 5 the first fraction. And if we multiply the denominator, we need to multiply the numerator. And in the second case, we need to multiply by 4. Both numerator and the denominator. And now we multiply 3 times 5 is 15. 4 times 5 is 20. 7 times 4 is 28. 5 times 4 is 20. Now 15 minus 28 is negative 13. And we know it's negative because the larger number is 28 and the fraction is negative. Then we cannot reduce this fraction, and this is the answer. This one is negative 13/20 is the answer. Now let's do the same thing for the problem number 2. Then we need to add these fractions, but they had different denominator. Then we need to find the LCD in order to get the equivalent fractions, to get fractions with the same denominator. Then the LCD of 8 and 12. If you know the LCD, just go ahead and write the LCD. But if you don't know, just what we have to do is list all the factors. It will be 8, 16, 24, 32, 40, 48, 56. Now let's see with these factors it's enough. The factors for 12, then we'll have 12, 24, 36, 48, 60. Now we can see the least common denominator. The least common denominator is 48. Then the LCD is 48. And now we need to write the equivalent fractions. Then the equivalent fractions, let's write here the problem, minus 3/8 minus 1/12. Then we need to get equivalent fractions as 48 as the denominator. Then here we need to multiply by 6, and we have to do the same thing on top, minus. Then we need to get 48, we need to multiply by 4, and we have to do the same on top. Now let's solve this one. 3 times 6 is 18, and this fraction is negative. 8 times 6 is 48. 1 times 4 is 4. 12 times 4 is 48. Now we had the same denominator, just we need to keep the same denominator. And in this case, because both numbers are negative, what we have to do is to add the numbers together and keep the sign. Then we add this number together, we had negative 22. And we can reduce this number, we can divide by 2 because the last number is even number. Then we can divide by 2. Then 22 divided by 2 is 11. 11. 48 divided by 2 is 24. And this is the answer. We cannot reduce this fraction. Then if we add this together, will be negative 11 over 24. And we want to add 3 7 minus 1 over 4. The step number 1 is we want to find the LCD. Yes, this is the step number 1. LCD 4 and 7. Let's buy in order. 4, 7. And if you know what is the LCD, go ahead and write the LCD. If you don't know what's the LCD, then just list all the factors for the for 4. Then will be 4, 8, 12, 16, 20, 24, 28, 32. And list the factors for 7. Then it's 7, 14, 21, 28, 35. And what is the least common multiple? The least common multiple is 28. Yes, it's 28. And the LCD is 28. Then the step number 2 is we want to find the equivalent fraction. This is equivalent fractions. And we want 28 as the denominator. Then to get equivalent fractions, what we had to do is for the first fraction, we need to multiply by 4, and we need to multiply by 4. Minus. And in the second fraction, to get equivalent fractions, we need to multiply by 7. Why by 7? Because we want 28 as the denominator. Yes. And 3 times 4 is 12. 7 times 4 is 28. 1 times 7 is 7. 4 times 7 is 28. Now we had equivalent fractions to the original fractions with 28 as the denominator. And because we had common denominator, just we operate this one. It's 12 minus 7 is 5, and it's positive because 12 is the larger number, divided by 28. Then this is equal to 5 over 28. And this is proper fraction, then we cannot write this one as a mixed fraction. The next, we want now to add together 1 over 9 minus 10 over 27. And what we had to do in this case, we want to, the step number 1 is to find the LCD. 27. Again, if you know what is the LCD, go ahead. You don't need to, you can skip the step to find the factors. But if you need to do that, just write the factors. Then 9, the factors for 9 is, the factors for 9 are 9, 18, 27. The factors for 27 is 27, 54. And now we can see this is the LCD, is the least common multiple. And the LCD equals to 27. The next step is find the equivalent. We need to find the equivalent fraction. Then this is step number 2. We need to find the equivalent fraction. Let's write the problem again here. 1/9 minus 10/27. We want equivalent fractions with 27 as the denominator. Then we need to multiply the first fraction by the 9 by 3. Then it's minus 1. If we multiply the denominator, we need to do the same on top. Here we don't need to do anything. We can just multiply by 1, but we will get the same because we want 27 as the. Then 1 times 3 is 3, 9 times 3 is 27 minus 10/27. Then we keep the same denominator, and then because both are negative, we add the numbers together and we keep the same denominator. Then now we move to the next slide. Here we want to find the LCD using another method, and sometimes is good to use the prime factorization when the numbers are larger, and it's hard to write all the factors. Sometimes you to write 20 factors is difficult. And in this case, when the numbers in the denominators with the numbers are larger, then we can use the prime factorization. Then how we can calculate the least common multiple or the least common denominators, which are the same, by prime factorization. Then, for example, if we want to find the LCD of 12 and 16 by prime factorization, the step number 1 is we need to find all the prime factors. And we can use the 3 method, the 3 method. Then 12, we can write 12 of 3/4. And 4 we can write by 2 times 2. Also, you can write 12 is also the same thing as 12, 6, this is 3, sorry, 2 times 3. Yes, you will get the same thing as is 2 times 2 times 3. It's the same thing. Then it's 2 times 2 times 3 are the factors. And we will do the same thing with the other numbers. Is 16, then we divide by 2 is 2 times 8. We can write this one like 2 times 4 and 4 2 times 2. Then 16 will be 2 times 2 times 2 times 2. The next thing we want to do is we want to write these factors using the exponents. Then we can write this 2 times 2 to the second, and just 3. You can just write 3 or 3 to the first power, or just 3. In this case, we can write this one using the exponents. We can write this one like 1, 2, 3, 4, 2 to the 4th power. Now, how we will calculate the LCD? Then the LCD you have to list all the factors. 2 and 3. 2 and 3. If the factor is, for example, 2 is in both numbers, you will list this one just one time. Okay? Just one time. 2 is 2, just one time. 3 is not here, but you need to list all the factors. If the factor appears twice, then just write 1. And now we will select the factor with the higher power. And we had 2 to the second, 2 to the 4, we will select 2 to the 4. And 3, just we had 3 to the first, then just will be 3. To calculate the LCD, we need to solve this one. 2 to the 4th power is 16. 16 times 3 is 48. Then the LCD of 12 and 16 is 48. After this point, is the same thing we did before. As once we had the LCD, is we want to add, for example, these two numbers, 116 plus 3 over 12. Then we know the LCD of 12 and 16 is 48. Then the LCD is 48. Then we want to get equivalent fractions. Then what to do is we want to get 48 in the denominator, then we multiply by 3, we multiply by 3. We want to get 48 as the denominator, for the second fraction, we need to multiply by 4. Yes, 12 times 4 is 48, and we had to do the same on top. Then now 1 times 3 is 3, 16 times 3 is 48. 3 times 4 is 12, 12 times 4 is 48. Now we had fractions with the same denominator. Then now this fraction is equivalent to this one, this fraction is equivalent to this one. Just we need to add the fractions, add the numerators together and keep the same denominator. Yes. 3 plus 12 is 15, 15 over 48. We can reduce this one. If we divide by 3, we have 15 divided by 3 will be 5, 48 divided by 3 is 16. And we cannot reduce this fraction. Yes, this is the final answer. And if we add this number together, the answer is 5 over 16. Then now we want to practice that. We want to add add or subtract the fractions with different denominator, but we want to find the LCD. We want to find the LCD by prime factorization. Then the step number 1 is to find the LCD of 24 and 36. Then to find by LCD, we need to find the factors. Then 24 equals to 2. Let's write first this. Then we can write this one like 2 to the third times 3. Yes, 2, 1, 2, 3. Yes, 1, 2, 3, 2 to the third times 3. And we can do the same thing with the 36, which is 2, 18, 2, 9, 3, 3. Then 36 equals to 2 times 2 times 3 times 3. 36 equal to 2 to the second times 3 to the second. Then the LCD equals to, let's write here, probably better, we have more space. Then the LCD, we need to select all the factors, 2, 2, 3, 3, but we will write just one time, is 2 times 3. Now, what factors to the higher power? 2 to the second, 2 to the third, then we will select 2 to the third. 3 to the first power, 3 to the second power, then 3 to the second. 2 to the third is 8 times 3 to the second power is 9. Then the LCD is 72. Yeah, this is the LCD. The second step is we need to create equivalent fractions in which the denominator, we want the denominator 72. And to do that, what we have to do is 5 over 24 plus, let me write here the problem, 5 over 36. Then we need to multiply 24 by 3 to get 72, then 24 by 3, but if we multiply the denominator, we need to do the same on top. And 5 over 36, we need to multiply by 2 to get equivalent fractions. Yes. Then 3 times 5 is 15, 72, 10, 72. Then now if we multiply this, if we add this number together, yes, because we had a common denominator, just we add the numbers. 15 plus 10 is 25, divide by 72. Let's see if I can write 72. Let me write here is 25 divided by 72. That's 25 over 72. Now let's do another problem. Now we want to subtract 1 over 16 minus 12 over 12. Then the step number 1, we need to find the LCD, but we want to find the LCD using 12 and 16, but we want to use the prime factorization. Then we need to find the factors for 16. Then we say the prime factors. We can write this one 1, 2, 3, 4 is 2 to the 4. Then for 12, 2, 6, 2, 3. And the prime factorization for 12 will be 2 to the second times 3. Then now, what are the factors? 2 and 3. And we'll write here the factors 2 and 3. We had here 2. We had 2 to the second, 2 to the 4th power. Then we need to select the larger power, is 4, and 3 is just 3 the first power. Then 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. Then the LCD in this case is 48. Now the second step is just we need to create equivalent fractions, will be 1 over 16. Let me write again here the problem. 1 over 16 minus 5 over 12. We want equivalent fractions with 48 as the denominator. Then to do that, what we need to do is multiply by 3 in this case, and if we multiply on bottom, we have to multiply on top. Then now we need equivalent fractions with 48 as the denominator. Then we multiply by 4 and we multiply by 4. And equals 1 times 3 is 3, 16 times 3 is 48, it's 20, 5 times 4 is 20 over 48. Then this, we just keep the same, 3 minus 20. And finally, we had 3 minus 20 is minus 17 over 48. Yes, this is, we had minus 17 over 48 is the final answer. Now, if we had three different numbers, we had 3 fractions, and we add the fractions together, then what we had to do is just we need to find the LCD for these 3 numbers. Yes, we need to find the LCD of. Then we will follow the same procedure: 6, 14, 21. And let's find the prime factorization for each of these numbers. Will be 2 and 3, and 6 equal to 2 times 3. 14 will be 2, 7. Then the prime factorization will be just 2 times 7. For 21 will be 3 and 7. Then the prime factorization of 21 will be equal to 3 times 7. Then the LCD, we need to list all the factors. We had 2, 2, 2. Yes, sorry, 2 and 2. We list just one time. Times 3, 3, just 1. 7, 7, just 1. Because we had the same power, just will we keep 2 to the first power. 3 is 3 to the first, 3 to the first, and just 3 to the first. Then in this case will be 2 times 3 is 6, 6 times 3, 7 is 42. Then the LCD is 42. Then in the second step, we want to find the equivalent fractions with 42 as the denominator. And let's write the problem here is 13 times 13 over 6 plus 5 over 14 minus 7 over 21. And let's create the equivalent fractions. Then to get 42, we need to multiply by 7 the first fraction, by 7. The second fraction, we need to multiply by 3. And the same thing we had to do here. For the last fraction, we need to multiply, this is negative, we need to multiply by 2. Seven, then it's 21 times 2, and we had to do the same on top. Then now let's multiply 13 times 7 is 91 over 42 plus 15 over 42, 14 over 42. Then now we had here 42. Common denominator, just go ahead. It's 14. That's why here. And this one will be 92. Yes, it's 14 minus 1 is 1. 91 plus 1 is 92. Divided by 42. Then because we had we had odd numbers, the last number is odd, then we can divide by, sorry, it's even, we can divide by 2. As it's even, we can divide by 2. Then 92 divided by 2 is 46. This is 46. 42 divided by 2 is 21. Then this is, we can now reduce more this fraction. Then the answer is 46 over 21. Maybe one thing we can do just to review, I don't have a space here, but I will do in this part. Then because this is improper fractions, we can just review, we can write this one as mixed fraction. Then to do that, we can divide, this is 46, 21, then how many times 21 goes into 46 is 2, is minus 42. Then we had 4, yes. Then this, another way we can write this answer will be, this is 2, yes. Then this, the remainder is the numerator, and the divisor is the denominator. Then this equals to 2, 4 over 21. Yes, this is another way we can write the same answer. Now let's do the problem number 4, and we want also to solve this, to add these fractions together or subtract, depending on the signs, using the prime, find the LCD by prime factorization. Then the first thing we want to do is we want to rewrite this number. You see we had 2 negatives here. Then we want to simplify that expression. Then we had minus, let me write here, minus 5 over 25. Negative times negative is positive, and this is the same thing we had here. And we need to find the LCD of 26 and 27. And we want to find the LCD 6 and 27. And let's write the factors for 6. Then 6 equal 2 times 3. For 27, then we have 9 here, 3, 3. And we can write 27, 3, 1, 2, 3, 3 to the third power. Then now let's find the LCD. The LCD equal to all the factors 2 and 3. Now 3 is to the first power, to the third power we will select the larger power. And finally the LCD equals to 2 times 3 to the third power is 3 times 3 is 9, 9 times 3 is 27, and this one is 54. And the LCD is 54. Now let's create the equivalent fraction with 54 as the denominator. Then let's write the problem again here, minus 5 over 27 plus 5 over 6. Now to get 54 we need to multiply by 2. That's 27 times 2, and we need to do the same on top. Plus, this is negative. To get 54 we need to multiply by 9. Then 6 times 9, and we have to do the same on top. That's why here this one. 5 times 2 is 10. 27 times 2 is 54, and this number is negative. Plus 5 times 9 is 45. 6 times 9 is 54. Then we can write this one like minus 10 plus 45, 54. Minus 10 plus 45 is 35, 54. And this is the answer. We can now reduce this fraction. And this is proper fraction, as we can now write this one as mixed number. The next thing I want to discuss is how we can compare fractions, how we can say if this fraction is larger than this one, or is greater than this one, or is less than the other one. Yes, we want to compare this fraction. Then it's hard if we had fractions in this way to know what is the larger, what is the greater fraction, what is the small, what is the less fraction. Then to compare this one, what we can do is we can create equivalent fractions. And we know to create equivalent fractions, we need to find the LCD of the denominator. This is we know. Then we need to find equivalent fraction. Then the step number one, if we want to compare fraction, the step number one is to find the LCD. The LCD of 2 and 8 is 8. This is, I think, is no problem to know this one. Then the next thing, we want to find equivalent fractions with LCD as the denominator. Then we know to get equivalent fraction, to get this fraction as a, here it should be 1, not 2. Okay, here it should be 1 over 2. And we need to multiply this one by, we need to multiply 2 by 4. Yes, 2 times 4 is 8. Then we need to multiply by 4 also the numerator. Then 1 times 4 is 4, 2 times 4 is 8. Then 1 over 2, 1/2 is equivalent to 4 over 8. And here we don't need to do anything. Yes, it's just I multiply by 1, but we need a as the denominator, then we don't need to do really anything here. And now we had fractions, we had equivalent fractions, we had fractions with the same denominator. Then now we can compare them. Now, how we will graph this one? Then how we will compare 4 over 8 and 5 over 8. Then because 8 is the denominator, what we will do is we will divide the interval between 0, you see 0 and 1 in 8 equal increments, in 8 equal parts. Yes, you see is 1, 2, 3, 4, 5, 6, 7, 8. Yes, and 8 over 8 equals 1. Yes. Then now the next thing is we want to graph these numbers on the number line. Then 4 over 8 is 1, 2, 3, 4. This is the first point, 4 over 8. And we know 4 over 8 equals to 1/2. Yes, it's here. And the second one is 5 over 8. Then 1, 2, 3, 4, 5. This is the second number. Now, always the number that lies on the right side is the greater number. Yes, now we can conclude, because 5 over 8 is to the right of 4 over 8, then 5/8 is greater than 4/8, which is 1/2. Yes. Then 5 over 8 is greater than 1/2. Yes, this is and the reason is this number is to the right. It lies to the right side on the number line. And now let's compare negative numbers and negative fractions. And the procedure is the same. If we want to compare negative fractions, we will do the same thing. the first thing we want to do is we want to find the LCD, because we want to create equivalent fractions with the same denominator, and in this way it's easier to compare the fractions. Then the LCD of 2 and 5 is 10. To find the equivalent fractions, then we need to multiply. In the first case for this fraction, we need to multiply 2 by 5, and we will do the same on top. We multiply by 5. Finally, we had negative 5 over 10. As this is negative 1/2 is the same as negative 5 over 10. Now we want to create equivalent fraction for 4 over 5 with 10 as the denominator. Then we need to multiply by 2 to get 10, and we have to do the same on top. Then 4 times 2 is 8, 5 times 2 is 8. And we know now negative 5 over 4 is the same as negative 4 over 8. Now, the next thing is we will divide the interval between 0 and negative 1, because 10 is the denominator in 10 equal increments, in 10 equals part. As this is 1, 2, 3. Let me use the mouse. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, here is 10. Now we need to graph the numbers on the number line. Then we need to graph negative 5 over 10 is 1, 2, 3, 4, 5. Negative 5 over 10, and we know this is the same as negative 1 over 2. Now we need negative 8 over 10. We know here is 5, 5, 6, 7, 8. This is negative 8 over 10, which is the same as negative 5 over 4, because they are equivalent fractions. Now, always the number lies to the right is the greater number. And in this case, we will say the negative 5 over 10 is greater than negative 8 over 10. Or is the same as we say negative 1 over 2 is greater than negative 4 over 5. And this is negative 1 over 2 is greater than negative 4 over 5. Then let's compare these two fractions. Let's do this problem. See if we can do all the steps. Then if we want to compare fractions, what we had to do, step number 1, is we need to find the LCD of 2 and 8 is 8. The next thing is we want to find equivalent fractions. Then it's minus 3 over 8. And we don't need to do anything because we want 8 as the denominator. For the second one, we want to write negative 1. We need to multiply by 4. By 4. Let me do something. See if I can. Then we want negative 1 equals to negative 1 multiplied by 4. Multiplied by 4 is negative 4 over 8. Yes. Now, because the a is the denominator, we want to divide, and they are negative. Then we want to divide the unit in 8 parts. And this is 1, 2, 3, 4, 5, 6, 7, 8. Here will be negative 1. That's negative 1. We want to divide this unit between 0 and negative 1 in 8 parts. the next thing is we want to graph these numbers. Then here is 0, -1 over a, -2, -3 over a. We had here -3 over a will be here. The other one is -4 over a. Then it's just here. Let me do something like that. -4 a. And we know this one is the same, like -1 over 2. Then now we can say, now we know what is the larger number. The larger number is the number that lies to the right. And we can conclude here is the larger number is this one. Then -3, we will say -3 is greater than -1 over 2, which is the same as -4 over 8. And now let's move to the next slide. And we want to compare 2/3 and 1 over 6. Then find the LCD of 3 and 6, and we know it's 6. Find the equivalent fractions. Then we need to multiply this one by 2 to get 6, will be 4, 6. And for the second one, we don't need to do anything because we already had 6 as the denominator. The next thing we want to do is we want to graph this one on the number line. This is 0, and we want to divide the interval between 0 and 1 in 6 parts. Then it's 1, 2, 3, 4, 5, 6. Yes, this 0 and 1, 1, 2, 3, 4, 5, 6. The next thing we want to do is we want to graph these fractions on the number line. Yes, we want to this one and this one. Then 4 over 6. This is 1, 2, 3, 4. And we know 4 over 6 is the same as 2/3. 1 over 6, then it's here. And now we can compare the fractions, and we know the largest fraction is 2/3 because this fraction lies to the right side on the number line. Then now we can say 2/3 is greater than 1 over 6. And this is all we will discuss in this presentations. Please stay safe, and we will discuss the other sections in the next presentation.